Hello and welcome back. So, because this is our second page of notes in this unit, you'll notice that at the top of the page there is a quick review. So, every set of notes from now on for the rest of the school year is going to have a quick review at the top. Notice that you do have a word bank. So, use the word bank to fill in those blanks in the quick review. Pause the video. Okay, you got your answers. Here we go. Everything in the world is made up of something. Scientists call this stuff matter. If something has mass, then it has a certain amount of stuff in it. If something has volume, it takes up a certain amount of space. One example of matter would be rocks. One example of something that is not matter would be love. Good job. So now we get to actually talk about matter. So yesterday, on the previous set of days notes, we learned about the ingredients that make up all of matter on Earth, and they are called the elements. The elements are the most basic components that make up all matter found on Earth. Two or more elements combine chemically to create compounds. So we talked on notes 1A about why sugar wasn't up there on the periodic table, because sugar is a compound. It's made up of more than one element. So what elements are found in the compound water? Well, if you look at the formula for water, it tells you what elements there are. H stands for, that's right, hydrogen. And O, good job, oxygen. So one molecule of water has two atoms of hydrogen and one atom of oxygen. And we know that by looking at the chemical formula. What about sugar? C6H12O6. What elements do we find there? C stands for, that's right, carbon. And then the other two are the same. H is hydrogen and O is oxygen. Those combinations of letters and numbers are called chemical formulas. And the chemical formula is like the ingredient list for the compound. So no, you can't just go to the store and buy a couple atoms of hydrogen and an atom of oxygen and make water. But basically that's what it is. It's an ingredient list. You can tell the difference on whether something's an element or whether it's a compound by looking at the letters and numbers that you're given. If it has only one capital letter in the set, then it's an element. If it has two or more capital letters, then it is a compound. So it will contain only one capital letter. All right, so I want you to look at these. Decide, is it an element? Is it a compound? If it's an element, circle it. If it's a compound, cross it out. If you're typing, if it's an element, put a circle next to it. If it's a compound, put an X next to it. Pause the video. All right, here's your answers. There's only one capital letter there. So that is an element. Do you know what element it is? Good job, copper. Okay, how about here? Tricky. That's a capital C and a capital O. That is a compound. Anybody know what it is? Carbon monoxide. Close. See, carbon dioxide would have two there. It would be CO2. So that one's carbon monoxide, since it only has, since it has no subscripts. It only has one atom of each. All right, the third one. Do I circle it or do I cross it out? That's right, I cross it out. Do you know what it is? Good job, salt. Excellent. All right, what about number 4? Circle it. Do you know what it is? Gold. You remember from the other day. Good job. All right, this actually is a typo. It should be NH4. But anyway, that's right. Cross it out. That is ammonia. That's right. Circle it. What is it? Good job. Carbon. Last one. I already gave you this one. Yep, it's a compound. What compound is it? Carbon dioxide. Good job. So there's also a difference between a compound and a mixture. So a compound is a substance that has been chemically combined. You're not going to easily separate it. You can't easily get the carbons and the hydrogens and the oxygens out of the sugar molecule. So it is chemically combined. But a mixture occurs when you have two or more substances, and it could be two compounds, it could be two elements, or it could be a compound and an element. And they're mixed together in the same place, but they are not chemically combined. You can do something to separate them back out. You can either evaporate one of them away and be left with the other one, or you can use a magnet and pull one of them out, or you can use a filter or a sieve to get particles of it out, or you can use a vacuum extractor with a filter on it. Like, if there's a way to pull the stuff out relatively easy without a chemical reaction, then it's a mixture. So like salt water, that's a mixture. I can get the salt back out of it. I have to evaporate the water away and I'll be left with salt. Steel is a mixture. It's a mixture of elements. It's layers of iron and layers of carbon. The layers are so thin that we can't hardly see them, but we can see them sometimes. You've ever seen those fancy knives that have like the beautiful stripes in them? That's when you can see the layers of carbon inside the layers of iron, making it steel. But that's a mixture because those two are not chemically combined. That iron and that carbon have not bonded together. They're just laying there next to each other. And if you threw that knife in a furnace, you could melt it. You could get the iron back and you'd have the carbon separated out. So it is still a mixture. So the individual substances can be more easily separated. So in a mixture, we can separate our two substances, three substances, however many substances. With a compound, we get a whole new substance, and it has its own set of properties. If you have a mixture, each substance keeps its own individual properties. So, for example, water by itself cannot conduct electricity. But if you put salt in it, it can, because salt is an ionic compound. So that ionic compound that salt is maintains its ability to conduct electricity. Just because it's mixed in with water doesn't mean it can't. And in fact, it can't when it's a solid. It can only do it when it's mixed in with water. So there you go. All right, again, this is a little trickier, but I want you to do it. Pause and decide. Is it a compound? Is it a mixture? So circle compound, cross out mixture. Pause, do it. Okay, soil. Soil is definitely a mixture. If you go outside and dig up soil, you're going to have little bits of rock. You're going to have little bits of silt, sand, little pieces of twigs, little pieces of leaves. You might even have like little bits of dead bug bodies or whatever. So soil is definitely a mixture because it's got all kinds of stuff in it. Salt is a compound. It is chemically combined. Sodium and chlorine chemically combined. Now, that's only one kind of salt, but we'll talk about that later. Salt water, though, is a mixture because you can separate the salt out from the water. Wood is definitely a mixture. There are all kinds of crazy compounds in wood, and they are not chemically combined. They're just squished all into one place together. Sand and water is a mixture because you can filter out the sand or evaporate away the water. Steel, I just told you, is a mixture. It's layers of carbon and iron. All right, there are 4 states of matter. What? Now, maybe some of you know, but most of you probably don't, or you've forgotten. So what are the 3 that you know? Right, solid, liquid, gas. Well, if you've used your context clues, right down here, it tells you what the 4th one is. It's plasma. Now, we're not talking about plasma like in your blood. When people go give blood plasma, it's different. We're not talking about your plasma screen TV. It's different. Those 2 types of plasma are, one's a colloid, which is solid suspended in a liquid, And one of those is a pure liquid. It might be a non-Newtonian solid, but either way, it's not plasma. Plasma itself doesn't really exist on the surface of the earth. It's too hot. But anyway, we'll get there in a minute. All right, so we've got this lovely little chart here. Now, I realize that you are not going to be able to draw very well digitally. I tried inserting a drawing. I tried all sorts of things. So please just do these drawings on your own paper so that you have them. Okay? Okay, thank you. All right, so we're going to define. So for a solid, what is our definition of solid? So we want to think about what is happening to a solid. It has a definite mass. It has a definite shape. All right, so liquids, they have a definite volume, but they take the shape of their container. All right, gases have no definite shape and no definite volume, and they spread to fill out the whole thing. All right, so plasma. Plasma, when we're talking about plasma, we're talking about stars, or we're talking about magma deep inside the Earth's crust, like way down deep near the core. We're talking about insanely hot. All right, so this is not plasma. Like I said, this is not the plasma. If real plasma was in your plasma screen TV, it would melt. If real plasma was in your blood, you'd be dead. Okay, because I mean, we're talking it's stupid hot. All right. Plasma exists at high temperatures and pressures. So again, this is not what is in your blood. This is not what's in your TV. Stupid high temperature, stupid high pressure would not be able to exist without it. All right, so the next row, we're describing the molecular action. So basically, what do the molecules look like in one of these? So in a solid, they are tightly packed together. In a liquid, they are loose and they can flow freely. In gases, they are spread far apart. And I'm being beckoned by. Okay, so y'all heard the students and I helped them. Here we go. So spread far apart is the molecular action of gases, and plasmas have no electrons. So the atoms do not have any electrons. They're just nuclei. So the nuclei, which is just plural for nucleus, the nuclei are tightly packed together. Okay, so no electrons, nuclei tightly packed. All right, this is where if you need to draw on your own paper, whatever, it's fine. But I really would like you to illustrate the way that the molecules look. So in a solid, usually they're represented by a square. People really like using cubes for this, but just, tightly packed together. To show that it's a solid. I don't know what shape that is, but it's something. All right, for liquids, because we know that it takes the shape of the container, I like to draw a container. My favorite container is the Erlenmeyer flask, which is what that thing is. So that's why I'm using one of those. If you want to use a cup or whatever, that's fine. But just show that the molecules are spread apart and yet contained within the container. For gases, we're going to illustrate the fact, you've seen this one before, that the molecules are flying all over the place, that they are highly active and spread apart. And then, I mean, honestly, that's about the best you can do for plasma. I mean, it's hot and bright and it's just a ball. you know? All right, I need examples. I need examples of solids. So pause the video and try to come up with at least one example of a solid, a liquid, a gas, and a plasma. Okay, here we go. Solids, I mean, anything that is solid. A table, a book, us, rocks, trees, scissors, aluminum foil, my glasses, solids. Liquids, anything that flows, water, juice, milk, coffee, liquids, rain. Gases, so these are the ones you can't see, but they're so very important to us. Things like oxygen and carbon dioxide are both gases. Helium is a gas. Argon, nitrogen gas, since that's the one that we breathe the most of. And plasma, really the sun, our sun, and other stars have plasma in them, and also deep within the earth, there is plasma. All right, pause that if you need to write it down. These elements, compounds, and mixtures can be described by their properties. The two main types of properties are physical properties and chemical properties. Physical properties are things that describe the substance using your senses, so odor, color, how does it feel, texture, and then also any things that you use using measuring equipment. So temperature, length, height, speed, all of those sorts of things are physical properties. So, for example, odor, color, size, shape, as well as boiling point, and then since evaporation point is this boiling, evaporation, and condensation point are all the same number, so that's one thing. And then freezing / melting point is the same number, so that's the same thing. So all of those are physical properties. Okay? Chemical properties describe the way that the object interacts with other things or interacts with itself, whether it explodes, whether it, whatever it does, that it has these crazy chemical properties. So things, for example, are acidity and basicity are both chemical properties. So what that means is pH. You've heard of pH level, pH scale, pH balance. Everybody wants their shampoo to be pH balanced and paraben free. Anyway, so we're talking pH, so acids and bases. So how acidic or basic is it? So if it has a pH of 0 through 6, it's an acid. If it has a pH of 8 through 14, it's a base. And 0 is neutral, like water. But that is all describing the substance in chemical terms and chemical properties. Combustibility is a chemical property. What do you think that means? Combustibility. Right. How easily it combusts, how easily it explodes. Yeah. How easily it burns. How easily, y'all, I can't write today. How easily it burns or combusts. And then the next one is reactivity. And yeah, you guessed it. Reactivity is how much does it react with other substances. Okay, so that is all of Notes 1B. Thank you very much for joining me. You do not need to share this back with me. This is yours for your notes to keep. You don't need to share it. Just save it in your folder if you did it digitally, or save it in a notebook if you did it on paper. Don't forget to do the next thing in the folder. There's a review activity to do after this. All right, guys. Thanks. Bye.